thank you all for joining us for the latest Cleanfax webinar, 5 Strategies for Improving the Drying Cycle, brought to you by Delmhorst Instrument Company. I'm Cleanfax Managing Editor Amanda Hosey, and I'll be moderating today's presentation. If you have any questions about the presentation, you can email me at this email here. Just a quick note about our magazine. Cleanfax is the industry's only dedicated print publication for both cleaning and restoration, and we offer practical solutions for contractors in the industry. In addition to our flagship print magazine, we offer regular digital content, newsletters, online exclusive articles, and a lot more. You can visit cleanfax.com to subscribe to our magazine and newsletters, and be sure to connect with us on social media. Here are just a few things to keep in mind. We encourage you to submit questions at any point during today's program in the Q&A box on your screen. Our panelists will answer as many questions as time allows during the Q&A section after their presentation. Your audio will be automatically muted to avoid interruptions. All attendees will also receive a recording of today's webinar by email, and a recording will be available on our website early next week. Thank you all again for attending. Let's get things underway. First, before we meet our speakers for today, let's hear a quick message from our sponsor, Delmhorst Instrument Company.
The next generation of moisture meter technology is here with the introduction of the Navigator series from Delmhorst. The new BDX20 and BDX30 meters are essential tools in your arsenal. Whether you are in the building trades, restoration and remediation, or building inspection fields, the BDX30 includes access to the Delmhorst Edge app for maximum convenience and flexibility. Experience moisture meter technology that packs all of the power of Delmhorst's 75 years of experience into a sleek, streamlined, cutting-edge device that makes your job faster and easier than ever before. For more information, visit us online at delmhorst.com today.
And just one more reminder that you can submit the questions for the speakers at any time, and we'll address as many as we can. Today, we'll be hearing from 2 of the most well-known voices in the restoration industry. We have with us today David Oakes, an IICRC approved instructor who teaches multiple IICRC certification courses for the Restoration Sciences Academy, including Applied Structural Drying and Water Restoration Technician, among others. David consults for both restoration contractors and insurance companies and has served as an expert witness in state and federal court. He serves on the IICRC Field Guide for Safety and Health for Restoration Professionals and is the current chairman of the ANSI S540 2021 consensus body. Also joining us today is Brandon Burton, an IICRC approved instructor of Applied Structural Drying and Water Restoration Technician courses, who currently serves as the IICRC Standards Chair and the Vice Chair of the IICRC S500 Standard for Professional Water Damage Restoration. Brandon is Vice President of Technical Application for Next Gear Solutions and serves on the RIA IICRC AIHA Crisis Response Joint Task Force. Thank you both for joining us.
Thank you, Amanda.
Thank you, Amanda. Yeah, good morning, everybody. I would like to start off this session, the first section, with smarter evaluations. And I'm going to introduce Brandon and ask him a question on that. How do we perform a better evaporation rate calculations? And what's new out there in the industry?
So, David, this is probably, there are a couple of questions that I would pose are real foundational to getting yourself off on the right foot for your drying strategy and the drying cycle, and understanding how evaporation is going to be occurring in the environment it's critical. It's key, and I think if we don't get started properly with this question and this assessment and this calculation, we're setting ourselves up for a whole lot of problems throughout the entire drying process. And so there are a few things that I would answer with additional questions about what we need to understand about the project. And first and foremost is understanding truly what's actually affected within the space. I think a lot of assumptions are made when we go into an environment and we see, for example, carpet, we see drywall, with a flat base paint or something like that. We see what visibly is wet based on where the water source is, and we make a lot of assumptions based on that. What we're dealing with in terms of a scope for that particular water loss or that water project. And many of us don't discover the challenges that are affecting evaporation, that are affecting drying, until we run into problems 2 or 3 days later, right? And all of a sudden we're either not seeing progress in an area, we're detecting odors in another area, we're seeing indications of water damage in areas that we didn't understand to be affected to begin with, or the job comes back to bite us a month later because there are unaddressed water problems down the road. So the first question we really have to ask ourselves is what truly is affected? And we're going to get into some of that as we go through the day today in the webinar, talking about some of the tools we use in making that evaluation. But it's really critical that we dig into the structure. And what I often say is understand the building on a component level, not just an assembly level, right? So the difference between the assemblies that are affected, like a wall, versus the components of that assembly that are affected. How's that wall actually put together? Whether that's the use of the proper instruments to get a feel for the wall, making inspections in areas where you can get some accessibility into the wall. But to get a good calculation, understand what we're dealing with for evaporation, you've got to get into the bones of that building and understand how it's really put together and how far that water truly has migrated in every one of those directions. So, and again, like I said, you're kind of starting off the conversation, I think that is one of the most critical steps in setting up your drying plan, your drying strategy, right? Because until I truly understand that, and I just rely on my assumptions, there are going to be problems that are going to arise through the process.
Does it have any effect how long materials have been wet and how deeply saturated or bound that water is on that initial consideration?
It does. And what's interesting, it's a great question, David, because it's interesting. That question is at the heart of one of the largest misunderstandings of the S500 that I'm aware of today. A lot of us look at class of water, which is the root, of assessing your evaporation rates, right? That class of water is my anticipation or my synopsis for what kind of evaporation I'm going to be dealing with. Well, at the heart of class is how deeply these materials are holding on to water. And there's an intention behind that class 4 designation. A lot of people think class 4 is just difficult assemblies. It's a hardwood floor, for example, or something like this. Well, not necessarily. A class 4 water damage means that water is deeply held. It's had an opportunity to truly absorb throughout the entire depth of that 3/4 inch plywood subfloor, right? And that's going to have a huge impact not only on your evaporation rate, but the duration of that rate and the complexity of sustaining that evaporation throughout the drying process. So, if we were to sit back and try to ask ourselves, what are the best strategies for improving my drying cycle? Well, a big piece of that is, how deeply do I have to dry into these assemblies? And understanding that is, how long has the water been present? How long has it had an opportunity to absorb? And that affects my instrument choices, my monitoring strategy, even potentially the types of equipment I'm going to use and how I'm going to modify that equipment installation over time, and the indicators I'll look for how to make those modifications. Great question, David. And again, I think yeah, go ahead.
I was going to say, when we get into the next section, this leads right up to what you're talking about here, is knowing the moisture contents of the materials and understanding that there can be gradients of moisture in materials. There's a general assumption out there that when materials are wet, they're 100% wet. And that's not necessarily the case. It depends on the duration of contact with moisture in the materials, the temperature of the water in the materials, the matrix, as you mentioned, the different types of materials that are involved. Having said that, initially, what kind of goal should we see within 24 hours in terms of RH?
Another great question. I'm gonna give 2 answers to that from my perspective. First of all, there are the goals that you would set for kind of your overall, what I want to achieve initially to know that I am truly mitigating, right? Preventing further damage from occurring in the environment. The second set of goals I'm going to set are the goals that I'm going to set to ensure that I'm properly drying. So you got 2 different things you're trying to achieve here. One is prevent further damage, mitigate, prevent humidity from damaging things secondarily. The second is that we need to actively promote the second law of thermodynamics and cause nature to drive towards a favorable equilibrium that we call drying. So I'll start with the first one. In terms of the first one, as an industry, we've often said, never let the relative humidity exceed 60%, right? It's an interesting number and a gross oversimplification of preventing secondary damage for lots of different reasons. Because you can get secondary damage, let's keep it really simple, you can get secondary damage from a lower relative humidity in the space, especially if you're in a geographic area that is not, conditioned to or accustomed to that 55-60% relative humidity area. The other thing that's really interesting about that is that I've often seen secondary damage occur not because the relative humidity in the room is exceeding 60%, it's because the relative humidity near those sensitive surfaces is exceeding a threshold. And that relative humidity of those surfaces can be drastically different than the relative humidity in the balance of the room, because the materials may be a different temperature, they may have their own little microclimate because of interstitial cavities and voids. There are lots of reasons why that humidity that you measure in the middle of the room is really irrelevant to what's going on at the surface, which kind of drives me to the second conversation. The other reason why we set humidity goals is to promote drying and to ensure that we're on the right side of equilibrium. We're drying things back to a normal moisture level. And I think one of the most common mistakes that we make as contractors and restorers is we don't take enough of those humidity measurements. Now, I'll give you one really good case in point. And I challenge anybody who's listening to this to give this a shot, give this an attempt. Take your thermal hygrometer at any point in the drying process. Take your thermal hygrometer and take that traditional kind of middle of the room measurement, kind of at chest height, and evaluate what the temperature and relative humidity are in that space in the middle of the room. Now take that same thermal hygrometer and place it down 1/4 of an inch off of the surface you're drying and see if the temperature and relative humidity match. They should. If they don't match, then you've improperly installed your drying system. Now take that same measurement and go to the next affected room. Go to the other end of your drying chamber. Go in that small closet in the back bedroom that was also a part of the affected area and check the temperature and humidity there. It should also match the temperature and humidity in the middle of that room you started with. If it doesn't, again, you've failed on the installation of your drying system. In other words, who cares if it's 85 degrees and 20% relative humidity at chest height in the living room? That air is doing nothing for drying the building materials that are affected. The air that's drying those materials is the air that is in direct communication with those materials. That's the air that's impacting those materials. That temperature is adding energy. That humidity is creating a differential in vapor pressure. It's not the temperature and humidity in the middle of the room. So again, a common mistake that I think that we make when we make these assessments is we assume that measurement I'm taking in the middle of the room is what matters, and it really isn't. That's a gauge, and you need that for a comparison, but then you evaluate how well you're distributing that air throughout the space, at the surface of materials, in adjoining affected rooms and affected spaces. And those are the goals that I'm going to set. If I want to have a low relative humidity, I want it low at the surface. If I'm going to have a good drying condition, I want it at the surface. So those are the measurements that actually matter. So when you set those goals, evaluate them in the proper location.
And Brandon, you mentioned setting up the equipment, but let's simplify that by saying, obviously, if we have the proper humidity control set up, but more importantly, the airflow to maintain that. And you made it a generic term of setting up equipment, but this is why I feel it's very critical, especially on the first day of drying, that we have airflow coming in contact with all those wet surfaces just to accomplish exactly what you're saying there. And this is where it is extremely critical and often misunderstood by sometimes our insurance partners, that we need this massive amount of equipment on the first day where we get the best value for it, because it pays off in shorter drying times and obviously less secondary damage. So, this is a loaded question, but how often do we recalculate these things? I know what the standard says, which is every 24 hours, but are there cases where we should do this more often?
Yeah, it's a risk-reward thing, right? So the best way to answer that in just general sense is that we should measure more often when the risk is higher, right? And what creates risk? What's creating that potential severity, to use an insurance term, and that's the amount of moisture present, the degree at which the moisture migrated through the space, the value of the materials. And often the way that I'll make that assessment is I ask myself the question, how long would it take for catastrophic damage to occur if my air movers kept running and my dehumidifiers shut off? How long would it take? And the very front end of a job, that's a much shorter duration. So I always argue that if you're going to recalculate more often, it should be in the first 24 hours of drying, where the risk is greater.
Two other considerations here too. One of those is the urgency to get back into a building. If you're dealing with a residential property, that's different than a commercial property that's shut down and there's loss of income involved. The other thing that you did mention, but to clear this up or expand on this just a little bit, is if you have an equipment failure, say a dehumidifier trips a circuit breaker or whatever, and it goes offline an hour after you leave the job site and you don't come back for 24 hours, you've lost 23 hours of drying, critical drying time, at a time when you really can't afford it.
And spread a lot of moisture around.
It does. And so it really depends on the severity, as you said, the materials involved, the urgency, the risk reward benefit. And I think in many, many cases, I think this is a weakness of our industry sometimes, is we do a job, we don't want to go out on the weekend and check it. And that's essential because we can lose a day or two of really effective drying.
And just a quick note on that, Dave, before we transition over to the next slide, one of the ways that I would ask or challenge those listening to deploy this is your first visit really should be 2 inspections at a minimum. What you basically do is you assess the environment, you install the equipment, and then you monitor the change in the environment from that equipment. In other words, before you pull off the project that first day, that first visit, you should see the environment and the humidity in that environment decreasing. You should see control. And it's something we're going to touch on with balancing a system here in a bit, but just to really drive that point home, even on that first visit, I'm going to inspect, if you will, or calculate more than once, just to ensure that I'm moving in the right direction.
That's an excellent suggestion, Brandon. I think we should all take advantage of that. Let's move on to the next slide then with that.
Perfect. And with this one, David, I'll jump in and throw a few questions your way. We'll talk a little bit here about locating moisture and really dig into the heart of instrumentation and some of the different technology that we use. Some of the common terms and vernacular are invasive meters and non-invasive meters and thermal hygrometers, and we can even get into thermal imaging. But let's start off with the basic. David, your thoughts on the use of invasive versus non-invasive moisture meters?
Well, initially, my first reaction is your invasive meter is going to give you the most accurate reading. There are some disadvantages, obviously, to a pin-type invasive meter, damaging materials, etc. But if you really have to know, you really want to have an invasive meter. One of the common mistakes that I see when people are using any meter, but especially invasive meters, is that they don't understand that meter has been calibrated for a specific material. And typically the pin-type meters that we're using are calibrated for Douglas fir. Standard that's uniformly used worldwide. And where I see a common mistake with that is they'll use that meter, say, on drywall and get a number that relates to moisture, but is not moisture content. It's a good number, something we can work with, but it's so often misused. That's the first thing. The other thing is you have to understand the limitations of the particular model and brand of meter that you've got. Some meters read on a pin setting from 0 to 100. Some read from 0 to 70. Some read from 0 to 48, or it's really not 0, actually more like 7 or 8 to 100. And we don't understand the limitations. So at times on a pin type meter, you can be reading, the meter can be giving you information that is not accurate because it's beyond the meter's ability to read that. And especially one of the things that I do like about a pin type meter is, in simple terms, basically when you're above 30 points in a wood material, you're dealing with liquid water. And that's a very valuable piece of information to me, just as you related in the last section. knowing what we're dealing with, and that water is going to come out very fast. On your non-invasive meters, and there is an issue here, mixing brands of meters, and there's the scales are different on all of the brands, and they don't relate to each other. So you can't use one brand one day and another brand the other day and have any kind of consistency and gather any decent data on it. I have to understand the limitations of the meter and how deep they'll read, understanding that they won't read, in most cases, air spaces. There are some meters that will read through air. And then the one big mistake that I see being used with the non-invasive meters is people are using them on carpet. I don't know why. Well, I get a number, yeah, but they're not designed for carpet. So that's a challenge that I've had and seen out in the field that just kind of frustrates me a bit.
Just to jump in on one of the challenges you stated, David, because it really hits home for me. That's the mixing of brands on the instruments. It's really, really difficult to get what you need from meters if you don't hold the process consistent, right? I'm trying to understand if a building's making any progress or not. Is it drying? Are we moving in the right direction? And I can't tell you how many times I've said this in training classes, but you have to use the same meter on the same place in the same way that you did yesterday and write it on the same piece of paper, if you will, in order to truly understand if you're making progress. And how important is that, right? How important is it for me to know if I'm making progress? I would argue it's the most critical question I'm trying to answer. So that's a great, great point.
I like the Southwest airline model. They fly 737s.
Yeah, there you go.
They bought another airline 2 years later. They had 737s. You go to Southwest Airlines, you fly 737. Cabin crews are trained the same. Pilots are trained the same. They all have the same parts. And so if you keep it simple, your documentation, the simpler you can make it, the more accurate it's going to be, more consistent it's going to be, and the more confidence you're going to have in the numbers you're getting from the field when you go to justify that bill at the end of the job.
Let's expand it just a little bit, David. Moisture meters versus thermal hygrometers versus thermal imaging cameras. Are all of these required in the kit? Are they all needed in the kit? Can one replace the other?
I think there are basically 4 essential tools that you have to have: an invasive meter, a non-invasive meter, and a thermal hygrometer, and a moisture sensor. Now, what combination that makes, whether it's a 3-in-1 meter or a 2-in-1, that doesn't matter to me. Thermal imaging cameras are a very helpful tool, but they're not essential. They're extremely valuable when you're trying to locate moisture. Now, keep in mind, a thermal imaging camera does not measure moisture; it only measures temperature differences. And typically, when you have wet surfaces, they're going to be cooler than the surrounding surfaces. So they're a great tool for inspections and locating moisture. There would also be a great tool if you're looking for temperature differences between dew point and trying to solve problems within areas. And they're not an essential tool. Good news is the thermal imaging cameras, the cost is very reasonable today to have one. But I don't think it's an essential tool. And I think you'd agree with me on that, wouldn't you, Brandon?
Yeah, my approach to thermal imaging is it's kind of like how frequently you monitor. It's kind of that same answer. It depends on the risk and reward, right? To me, thermal imaging, where it's good, where it's valuable, is helping assess, just as you had mentioned, how the water has migrated, especially in complex water damages. You get into commercial losses, multi-floor losses, where it's really difficult to tell where that electrical chase runs through the floor and drops down into the next floor. A thermal imaging camera can be helpful for assessing that, but not for measuring the moisture, but for adding to my analysis for where a moisture meter needs to be used. That's probably the best way that I could describe it from my perspective. It helps me to identify areas of additional inspection.
I think also there's a tremendous value to the visual effect on the thermal imaging camera. We were working on a project that was a 3-story apartment complex. Water came from the 3rd floor down, and we went into all of the apartments that were anywhere close, and people said, we don't have any water. Took a thermal imaging camera, and we could see cool spots. Then we put a meter on it, and sure enough, we were able to visually present to the tenants that there was a problem there.
Yep,
and something that could have been very easily overlooked if you were trying to go in with a non-invasive meter and check all the surfaces in that apartment in a timely manner.
Absolutely. So in essence, the time will roll over to the third slide. David, I'll hand you back the floor if you want to introduce the next topic.
Okay, well, we're going to look at better equipment choices, and this is a topic that is near and dear to everybody out there because everybody just loves equipment, and there is a lot of different things going on with equipment. And I'll lead off with that question, that first introduction. How do we balance humidity, airflow, and temperature or energy within an environment?
So the most important thing to think about here is the importance of balancing these three, and how do I assess that? How do I know if we are in balance? So real quickly, I'll first address that if any of these three are not in a proper balance, then your drying environment quickly becomes an environment conducive to damage, not to drying. So it's really critical that we are in fact in control and properly affecting all three of these. And I'll give you a really quick case in point for what happens when we don't. If I have really good airflow distributing air through the space and my conditions are the same in every single area where moisture exists because I've got good airflow, but my humidity is at 80-90% relative, at a warm temperature, then all I'm really doing is distributing a mechanism for damage, right? And if I have really good humidity, I've got my humidity down, low grains per pound, low relative humidity, and a good drying temperature, but there's no airflow, then that condition won't exist on the wet surfaces where I'm trying to dry. So it is very, very critical that we do balance these, but how do we do that? And how do we know that we have? And again, the key is something I alluded to earlier. The key to understanding whether or not you've properly balanced these is by using that thermal hygrometer in more places more frequently. This is one tool in the inspection kit that just does not get used enough. Use it near the surface where you have wet materials. Assess, is the temperature and humidity at that surface where drying is actually happening, at that surface, how does it look? Does it look the same as the temperature and humidity, 3 or 4 feet up in the room? And if it does, then your air movement is effective. You have good balance on your airflow. Understanding if humidity balance is proper means you have to assess the humidity over multiple times on the timeline. What direction is your humidity headed over time? And by humidity here, the only way you can assess that would be through grains per pound because your relative will fluctuate with temperature. So is your humidity ratio, your grains per pound, is it reducing over time? And if it's not reducing over time, why? And this is another big common mistake that a lot of people will make. They'll see the humidity increasing over time, and they think automatically, well, if my humidity is getting higher, that must mean I don't have enough dehumidification. That's like the knee-jerk reaction. So they fix it by adding dehumidification. That may not be the problem. You may have enough dehumidification, but the reason your humidity is increasing over time is because the homeowner's turning off the dehumidifiers every time you leave, right? Adding another dehumidifier doesn't fix that. All it does is give them another power button to push when you leave, right? So you have to truly assess the problem and understand the source of the problem to balance that humidity. I'll give you just a few examples of what it may be. It could be that there is a humidifier in line with their air conditioning system. It could be there are affected areas that you didn't identify. It could be because you accidentally left the dump valve open on your truck mount when you extracted and you didn't extract properly, right? It could be a lot of different things. And if you don't assess the true source of the unexpected evaporation, you're going to apply aspirin to the headache when the headache is telling you you have a bigger problem, if that makes sense. So by balancing, what we mean is truly identify the source of the problem. Humidity should be decreasing and it should be consistent throughout the entire space. Now, last but not least is energy. Energy, basically adding energy into the drying process takes all of the discussions we just discussed and multiplies them by a factor. The more energy I put in the environment, let's just keep it simple. Let's just say temperature. The warmer that environment is, the more energy I'm adding into that environment, the faster both drying and problems occur. All right, and the more extreme those drying results and problem results can be. And we'll get into energy a little bit deeper because I know that there's a point here where we're going to talk about it a bit deeper. But what it does is it raises the game. All right, and it increases the need for more frequent monitoring. It can be very effective, but you've got to watch it very closely. We'll come back to that.
There's a question on selecting dehumidifiers, and I'd like to take a moment and just comment about that. I see a couple things going on. There's a lot of equipment that's been around for a long time, and some of it's very good and durable equipment that works very effectively. And specifically to dehumidifiers, your older dehumidifiers were designed at a point to work at 80 degrees, 60% relative humidity. And that is not a point where we typically see our equipment running in most times. So
Yep.
modern equipment is designed at a 80-30 configuration, and whatever AHAM numbers are there, whatever they are. So, and I'm gonna balance this comment by geography a little bit here. In some parts of the country, it would be essential that you look at your equipment and look for more modern equipment to get those lower RHs and better grain depression. On the other hand, in other parts of the country where you know, some parts of Texas and Florida and the southern coastal regions, the other equipment works fine because of the naturally high occurring humidity. But I think it's important to understand that if you're using an older technology, there is a significant difference in the equipment built today in terms of how they were designed, how they remove water, how they deal with that temperature issue in particular, the sweet spot that we like to dry at 70 to 90. And I think that's an important consideration. And one last thought on this equipment deal. I'm often reminding my students that a dehumidifier is not a water collection device. It's a moisture control device. And if we can maintain low relative humidities, and if we get and materials are drying, and we can manage those other factors with the airflow and the energy and temperature, then it's doing its job. And too often, I think, especially some of our insurance partners will look at that and say, well, you have very low grain depression, but they fail to look at the relative humidity and the drying conditions. So you can't take one of these things out of context. You can't take just airflow. You can't just take heat or energy, and you can't just take humidity control. They have to be balanced, and that balance changes in the drying cycle.
And that's a great point, David. The dehumidifier is about the environment it maintains. It's not necessarily about the water it produces. It's a great point. I'm going to jump us down into the AFD discussion because this has been a hot topic of recent, and something I'll touch on a little bit at the end of this when we talk about the 2021 S500. But air filtration devices are an important part of the drying cycle, and they've become a more and more important part of the drying cycle over the course of the last 10 or 12 years. And I often get the question, you know, do I need to install an air filtration device on every single water damage? Do I always need them? And the question, or the response to that is it depends, right? The way the S500 addresses it is it states that, you know, you need to have an environment where, you know, basically it's, you know, it's safe for your workers. It's also a clean environment for those that are reoccupying the space, and air filtration devices can play an important role in that. What you have to ask yourself is, you know, is there a concern for dust, dirt, and debris in this space, especially during the drying process when air movers are moving air through the space? If there is, can I clean it? You know, is it possible for me to remove, you know, any contaminants that I may be concerned with in that space so that an air filtration device wouldn't be necessary? The other thing you've got to ask yourself is, are there any immune compromised individuals or anybody at risk for aerosolized particulate? And if any of these come up with red flags, document the red flag and use an air filtration device. And I think what you're going to find is that in more cases than not, one of those questions is going to raise a red flag. It's going to give you something that you can commit to paper, commit to your documentation, and justify the use of an air filtration device. If none of those raise a concern, then the value of an air filtration device isn't there. So a logical approach to understanding why you're using the air filtration device is the first step there. So just as a way to address that. I'll ask you this last one on here, David. Building containment and ensuring adequacy of my drying system. You know, should I be using containment in a general drying approach?
The answer to that is it depends, and that's the problem with our industry. Is it's a very fluid industry depending on the situation that you're in. If you cannot control the drying environment in the area, you should put up containment. If you have or are concerned about contamination, you should build containment. But as a general rule of thumb, we don't put up containment like we would do in mold remediation on every water damage job. It goes back to what we started with on, how do we manage that evaporation? And if we can't get a handle on it because we have some outside forces, whether it be changing weather conditions, whether it be the building envelope itself, a real common one that I would see is as a business that may be open where you have unfavorable conditions outdoors and people are coming and going and opening the doors, walking through the door, and you just really can't manage that and control that environment. You may want to confine that drying area to a smaller area where you can have better control. The advantage of containing that is you can take a smaller dehumidification system and make it work like a very big one if you can reduce the size of the space that you're managing. And when you have more control over it, you're going to dry quicker.
And I just to segue off of that, David, the way I generally approach it as a rule of thumb, from a drying perspective, a containment can be valuable just in controlling the environment. Generally, if you can reduce that airspace by half or more, right? If I have a very large open space and only a small portion of that space is affected, and by erecting containment, I can eliminate more than half of the airspace that I would otherwise have to manage with the dehumidification, et cetera. And generally I find it's energy efficient, cost efficient to put up some sort of containment. But just like you said, I'm not talking about putting up double layer critical barrier containment with zippers and monitoring it with a manometer and everything else. I'm just talking about putting up a couple of zip wall poles and a sheet of plastic and making it so that I can contain that lower humidity air relatively to the space I'm drying. But it really doesn't give you a lot of efficiency add, I should say, if the area that you're dealing with is greater than half of that space. You start to really lose the efficiency or any gains that you would get from erecting some sort of containment. Having said that, though, there are other reasons for it, right? If there's a contaminant of some sort that I'm trying to control, or maybe just trying to keep people away from the equipment that I'm operating. So maybe the containment's the other way around. I'm trying to keep people out versus in, right? So there are other reasons why that containment can most definitely be valuable. So with that, let's roll over to the fourth topic here and talk a little bit more about documentation. So a couple of questions I was going to throw your way on documentation here, David, to get us started. First of all, if you were to pick the 3 or 4 best practices with documentation, what best practices or behaviors or habits are critical to documentation?
Well, for me, it all starts with management. And it sounds like a silly thing to start with because we're talking about water damage here, but you have to have a system in place that becomes consistent and repeatable on every job. And it has to be practiced, and it typically takes 6 weeks to develop that habit. And it has to come from management down. It doesn't come from the bottom up. And you can't have one technician say, well, I like to do it this way, and another technician saying, I like to do it that way. Imagine that at McDonald's. Your hamburgers would never be consistent. And so we want the McDonald's motto out there. We want to be consistent with what we do, down to the point of how you hold the meter. Now, with documentation, and I'm gonna bounce this back to you, Brandon, because you have a better insight to that because of your position. But I am somewhat frustrated by our industry not moving fast enough to tablet-based or electronic documentation. It is so much easier than paper. A good paper system works, don't get me wrong, and it works extremely well. But what I see with the electronic documentation is built-in consistency and built-in steps that you have to go through. And I had an odd one in one of my students that they said, well, they take it in the field on paper and then we put it on the tablet at the office. I said, well, why bother? And I'm gonna press this question out to the audience. I don't want an answer. I just want you to think about this. You go to a restaurant, any podunk little restaurant in any town, and they come up to your table with the device and swipe your credit card. And we're out there with a pencil and a piece of paper doing documentation on something far more important. So, Brandon, I'll put that to you and see if you put some more light on that documentation subject.
Yep. The first thing I want to do is I want to take the example of using paper in the field and then transferring that to electronic back at the office. I want to expand on that for a bit. Unfortunately, when you do that, you're taking the worst of both worlds and putting that in your process, right? Because the challenge with paper is interpreting that and having to transcribe that information to communicate it, right? Your half-life of information, that's the way I've heard that described before. I think it's a beautiful way to describe it, because every time you have to interpret, transcribe, and then reproduce, something gets lost, right? Something gets lost in that translation. So if you're having to document it in the field, transcribe that information, document it again in digital, and then send that out, the reputation and liability of your organization is now going to have that additional kind of missing link in its armor and the integrity of that information. So I would much rather, if you're doing paper in the field, I'd rather you stick with a paper method, quite honestly, than having to translate that information to digital and send it out. The real benefit behind digital is skipping that paper step, right? So that it's very clear what's being documented, and it's being done in a method using a mechanism or a container that controls the consistency, as you touched on earlier, David, so that we understand exactly what meter is used, what setting it's on, what materials being investigated. But any tool, even a digital tool, is only as good as the user of that tool. And I think just like if I were to grab if I'm business A and I go grab the paper documentation from business B without any explanation or knowledge of how to use it, and I go out in the field and I use that documentation from business B, I'm not going to use it effectively, right? And it's the same with digital documentation. If I grab a digital tool and I go in the field without understanding how to properly use it, I'm not going to use it effectively. So I think any documentation system, whether it's digital or paper, it doesn't really matter. That system needs to be used in an educated and purposeful way, where everybody uses it the same way. Because to me, the most important thing in documentation, the one most critical element to it, is consistency. It's consistency in the way it's used. I often use the phrase, because I've done this in training with contractors, that I don't really care how an organization, uses and writes down the information from example, a hammer probe, right? There's a million different ways to do it. The only wrong way to do it is differently than the technician did on day one on that same job. That's the only wrong way, right? It has to be done the same way. Same thing with a non-invasive meter, and how the non-invasive meter is used, and the direction that it's held, et cetera. It doesn't really matter to me as long as you're consistent. Consistency is key, because I need to know if we're making that progress, right? And I can only do that if those things are being done consistently. Having said all of that, I'll close out that topic by saying I do have a bias towards the digital space. I think the digital world is a world that allows for a lot better accuracy in the information, so really streamlines communication and allows a lot of other efficiencies to be brought into the business with process control and SOPs and things like that. Having said all of that, though, if the tool's not being used right, it's no more valuable than a paper system.
And Brandon, I'm gonna add to that before we move on to the justifying equipment usages and common mistakes here. But one thing that you mentioned, but I think most people overlook, is the single most expensive thing we have on the job is labor.
Yep.
And if we can save time and pass that savings on to our clients and our insurance partners, we position ourselves much better in the market. And I know a lot of people say, well, I don't want to spend the money to get into the digital and go through the headaches of training people on how to use it. It pays off tremendously on the bottom line, and with the efficiencies that you produce for your client and the profitability of your own company. Having said that, justifying equipment usages and common mistakes is one of the things that we talk about frequently in our courses about why we get paid. And one of the common things that I see is that insurance companies are using the formulas that we're using in the standard and using that only as a means of justifying the equipment on the job. And how do you get paid for that equipment? I often say that anytime we're having a struggle with our insurance partners on getting payment, that the problem is with us. It is not with them. And we have failed to adequately communicate with them what we're doing on the job and for them to understand the reasons what we're doing. And I often say that we need to answer the question before it's asked. And then we have to have a firm understanding of what we're doing on the job site. And sometimes there's a disconnect I see within companies where they'll have the technicians on one side and then they'll have a collection department on the other side. Well, really the person that is answering those questions should be the technician or the project manager. They can say, this is why we did this. And look at these numbers. If you look here on the third day, the relative humidity is down at 32% RH, moisture content and materials are coming out and materials are drying. And you're telling me you don't want to pay for that piece of equipment on that job when it's working. I see that as the problem. The idea that a lot of contractors just go out there and put that on there and say, just because I said so, doesn't work. You need to back it up with documentation, which I can go one step further in saying that is you use the standard properly. Don't say according to the IICRC, or don't even say according to the S500. I want you to say the ANSI S500 standard for water damage restoration 2021 edition 12.2.2 and quote and paste that in there why you're putting the equipment on the job. So give them that documentation to justify it.
Yep. And that really works best when your documentation is taken daily. Right? You can show that daily progress, right? Which I think is another key to defending your equipment decisions. Because what you're going to find is that if you start with what is recommended by industry standards for quantities of equipment, you monitor daily and adjust based on the results of your monitoring, then everything has a story behind it, right? You have a chain of custody, so to speak, for the decisions that are being made, which will serve you, time and time again in those types of discussions. And then, as David said, preemptively understand those questions that are being asked. I don't think notes are included enough with those changes that are made to drying equipment so that you can preemptively say, on day 3, we made this change. We made that change because we saw this reading did this and not what we expected. So here was the adjustment. By the way, on day 4, it was then making progress, right? So preemptively understand those questions that are going to be asked. And it's a lot of work to do that documentation, but yet another reason to consider, the digital space, because it can help with that. So with that, let's jump over into the safety topic. I want to save a little bit of time for an S500 update here at the end. So David, I'll give you back the floor here on the topic of safety.
Yes, and safety is something that has become very important to me. Always been involved with safety throughout my entire career, but early on in my career, I spent time doing safety because I kind of had to do it, try to avoid fines, that type of thing, not really understanding the real benefits. Obviously, I didn't want to put a person in a position that was going to be harmful to their health. But I've come to realize now that safety is a profit center. And it's not because we can charge extra for the things that we're doing. I mean, you need to charge for what you're doing. There's no question about that. But when you do safety correctly and you sit down and do it in a formal manner, and I know it's difficult to do for a small business when you've got 1,000 things going on and you're trying to make payroll and deal with customers and all of this. But if you sit down and carefully analyze every action that your company does and identify the potential safety risks, once you've done that, then you develop a standard operating procedure, and then you develop any things that you need to do to either eliminate or reduce or those risks, or to come up with the proper personal protective equipment. What you've done is you've systemized your processes. And when you do that, you become extremely efficient. And because most companies are charging on a unit basis, not by the hour, it really doesn't matter how long we take to do the job. We're going to get the same dollar return for that specific action. If I can get that action done more efficiently, I make more money, and that goes straight to the bottom line. And this is where I see safety as a key component to that. And you go on further about why it's important to have employees that are healthy, because a sick employee doesn't make you money. I'll just make one little quick comment here. One of the things that I've done in my company, and I had offered way before the COVID thing, flu shots to my employees. Today, if I still were in business and had the company, I would offer flu shots to my employees and their family. I wouldn't require them, but I'd offer it. Because if an employee is sick, they're not working. If a family member is sick and that employee has to take care of them, they're not working. So just from a practical business standpoint, it's a profit center to me. It's also the right thing to do. So maybe it's a little bit different perspective than some other people look at it, but I see safety as a profit center. If you do it right, it becomes much more efficient.
So I'll add a quick layer to that cake and just state that safety is also something that needs to be a part of culture in your organization. David mentioned a bit ago that the most expensive thing on a project is labor, because the most valuable asset your organization has is people. And you can actually use safety as a culture of a way of valuing people, right? The more you value safety and value the safety of your employees, even subliminally, that really communicates care to those employees. So those organizations that I've truly seen as becoming the greatest in our industry are those that really value the safety principle within their organization. So with that, we'll roll over to kind of the final topic we're going to touch on here, which is the S500. And I just want to touch on a couple things here with the S500, because I know most of you hopefully have had an opportunity to become somewhat familiar with this 2021 update. But because it is such an important topic in our industry and current, I did want to touch on it here briefly at the end of our webinar before we roll to questions. The 2021 update was a pretty significant update to the S500. It had two primary objectives. Objective number one was to remove the reference guide. So there is no longer a reference guide in the S500. It used to be the standard and reference guide, now it's just the standard. The second impact that had on the document is that a lot of the content that was in the reference guide that was really important to the standard got pulled up into the standard, so it wasn't lost in when that was removed. What that did is it took the actual standard section and made it substantially longer. So the actual, what used to be blue pages, if you will, in the standard are now a greater number of pages, even though they're not blue anymore because we don't have a standard reference guide. Having said that, there were a couple of things that were retained as appendixes in the back that are not part of the standard, but were still really important information. So I'm just going to roll through these bullets real quick and give you a couple of updates on each. First of all, terminology. A couple of terms were updated. Some things like drying plan were defined. Category 3 water got a change in definition, which is quite substantive. And some other terms were updated and refined. The Category 3 definition update, in my opinion, is pretty significant. In general, that change went from water from beyond the trap. In a plumbing system, Category 3, the word any was added. So water from beyond any trap in a plumbing system, regardless of visible content or color, which really removed any sense of doubt about whether or not water coming from a plumbing system that has a trap integrated in it being Category 3 or not. There were also some equipment requirement adjustments that were made in the S500, not to the number of air movers, not to the number of dehumidifiers. Very little change there at all. The air mover section is still in the standard as standard of care, an air mover for every 50 to X square feet, depending on what we're dealing with, or your wall assemblies, etc. The dehumidifier requirements were retained as an appendix. They were never part of the standard. They're still not part of the standard. The only thing the standard requires is that you have a method for determining how many dehumidifiers. And by the way, look at the appendix. There's an example, couple of methods back there, as opposed to being in the reference guide. So no real substantive change there. But air filtration devices did get a substantive change. Air filtration devices were a mention in the reference guide before. They are now a mention in the standard of care. And basically, it is a recommendation that air filtration devices be used if there's a concern for particulate that can effectively be cleaned out of the space, or, not and, or there are immune compromised individuals present. All right, so if you've got a concern for particulate and cleaning won't take care of it, or there are immune compromised individuals that occupy the space, it's recommended that we use one or more air filtration devices. Okay, so that is a substantive change, and that is very different from the position of the document prior years. Roles of third parties and documentation needs. there is a section on documentation in section 10 of the standard that gets into great depth and detail about what is required for documentation on a water damage mitigation project. I'm not going to cover it all here because we don't have time, but there's a long list of you should maintain the following documents. And what you're going to find in there is a record of your moisture levels, a record of your temperatures and humidities, a drying plan, a certificate of completion and satisfaction from the customer. These are all things that were mentioned previously, some of them recommended previously. They are now standard of care. So one of the homework assignments that I give to everyone on this call is go to that section in section 10 of the S500, read through the required documentation, compare that against your flood files, and make sure that every one of those required documents gets a check on the box, that you're maintaining those in your documentation. And then last but not least, I'll touch on role of third parties. There was an entire section on third parties within the S500. It used to be section 12. That was removed from the document. It no longer exists. Instead, the role of third parties is discussed in step with those sections that discuss those third parties. For example, all of the information about properly trained third parties that might do an assessment on a sewage project are now discussed right where category 3 water is discussed, not as a standalone section later in the document. So it didn't change the document substantively, it just reorganized the information. So when you look at the S500 and you don't see third parties as a section, don't make the assumption that third parties are no longer necessary, I guess is the moral of that story. They're just discussed in the appropriate section. So with that, there is your very, very brief S500 2021 update. And I'm going to roll things back over to Amanda, who is going to ask a few of the questions that came in on the Q&A. Amanda, your floor.
Hey, thank you guys. All right, that is the end of our regular presentation, but we are going to move over to the Q&A section in just a moment. Thank you both, Brandon, David, so much for the presentation. And I know there's several questions from the audience right now. And just a reminder, you can still submit questions, and we're going to try to address as many as we can. We're going to roll the program over for until about 15 after. So if you can stick around, please do.
One of the questions that came up in the Q&A that I thought was, a really good question was, and then there were several. I don't know if you were tracking these, David, as you were going through, but I've got about 15 or 20 of them that came through. But we'll start off with the very first one that I saw. Do you recommend heat on a drying project, virtually on every drying project, or are there limitations to when heat should be deployed? So, and this is a loaded question. There's a whole lot of ways to address this. So I'll give you the floor first here, David.
All right. Well, when you say, do you recommend heat on every job, means I've got a heat machine and I want to use it on every job. That's what it sounds like the question is to me. My answer to that is heat is a very, very valuable tool, but like anything, it can cut both ways. I have used heat to dry buildings in the summer because it was necessary. On the other hand, heat out of control can create a tremendous amount of problems. So it's like any tool used properly and in its place, it can be very, very effective. But heat alone, without balancing airflow and humidity control, can be a real problem. And the other side of it too, I have some real serious concerns about high temperatures when I have liquid water and materials. I just have a real concern about that, just serious concern. And when we talk about heat, here's one of the fun things about it. Our systems produce heat. Our air movement dehumidification system produce heat. They throw off BTUs. And it just so happens it throws off BTUs when we need that extra energy towards the tail end of the drying job. Yeah. And so I'll leave it at that.
So the one thing I'll add to the heat discussion is, and it's not always true, but generally this is true. When you dry a building by using dehumidification, you lower vapor pressure and generally draw moisture out of building materials. Now, water is going to be moving everywhere. It's all going to move three-dimensionally throughout the space. It's always going to move from high vapor pressures to lower vapor pressures. But by decreasing the vapor pressure in the drying environment, you're generally drawing the moisture out of materials as it's still driving itself deeper into assemblies. You're just hopefully drawing it out faster, right? So you can keep up with it. When you add heat, however, to those assemblies, So you take whether it's a concrete slab or 2 layers of drywall and a wall assembly, whatever it is, especially when the liquid water is present, because that's when it happens the most, and you heat that moisture. What you're doing is, instead of decreasing the vapor pressure in the space, you're increasing the vapor pressure where the water exists. And what you can do is you can actually drive a lot of moisture at a faster rate deeper into those assemblies if you're not careful, which may be fine if you're ventilating the assembly, right? As long as I'm drying on both sides, great, have it come out in every direction as fast as it can. But you've got to understand that by adding more energy, you're increasing the partial pressure of vapor associated with that vapor leaving that liquid. And by increasing that pressure, right, you're exciting, as I mentioned earlier, it's like multiplying, by a number of factors, the rate of that moisture movement. Great as long as you're monitoring frequently, you know where it's going, you're tracking it, wonderful. Just make sure you're in control, because adding a lot of heat is like strapping a rocket to your back. All right, you've just got to make sure that you know where you're going.
Good analogy, Brandon. Amanda, you got another question for us because we took the heat one?
Yeah. Can you tell me, do you have any tips for switching from using paper documentation to transitioning into using digital?
Yeah, I'll grab that one, David. The first tip I have for you is patience, because anytime you make a change to that type of a system, it's going to require organizational commitment, right? And it's going to take some patience in order to get through that transition. Change is never fun. Nobody likes change, right? Especially the technician in your organization that's been using the same paper system for the last 15 years. That's the way he's always done it, or she's always done it. It's what they're used to. And then getting them on to an iPad or an iPhone or an Android or whatever it is, that's going to be a painful process for some people. And it's going to take them time to adjust. But patience is a virtue. The payoff is worth it. For those that are making that kind of a transformation, but you've got to stick with it, just like any other change you would make. I could make it akin to what we just all went through with COVID, and that, to me, what's near and dear to my heart is my kids going from going to class every day to doing virtual training on their computers every day. That transition was extremely painful. We got through it, but it took patience, right? And actually now I'd almost prefer they stayed that way because we learned how to do it. So it's just patience.
Brandon, I'm going to add to that very quickly as a practical standpoint. When you're dealing with a change, such as going to electronic documentation, I approach this in my company this way. Hey, we're thinking about going to electronics, and here's what we're looking at. And then 2 weeks later, we're still working on this. What do you think about it? And then 2 weeks later, this is the system we're looking at. And then 2 weeks later, I kept on doing that for about 6 months until, we're going to do this. It's kind of the power of the penny that the post office uses. They raise the price of stamps, but they don't do it tomorrow. They tell you 6 months out. So by the time you get there, the mad is already gone, so you're accepting that change.
Well, and also understand that there is no such thing as completing any process. No. Right? When you move to a digital tool, it's just like moving to a different paper tool, or even sticking with the same paper tool. That process is going to change over time, and you're going to improve over time. You always work on the process. You always work on the process and always improve.
Okay. Amanda, we have another question there.
How often should you have a non-invasive meter recalibrated? Great
question. So if you don't mind, David, I've got a thought on that one. So calibrating your meters means something a little bit different in our industry, okay? Because you don't really recalibrate your moisture meters per se. What you do is you ensure that the meters in your business are consistent with one another. So here's the process. Here's your standard operating procedure. At a minimum of once a week, and I would actually encourage that it be done a bit more often than this, but at a minimum of once a week, you just take inspection kits 1 through 10 or whatever they are, and you put them all in the same little chunk of 2x4. If they all read the same number, then I don't care what the calibration is set to. They're consistent. That's the key. They're consistent. Now, if kits 1 through 9, I'll read it as 10, and kit 10 reads it as 22, then 22 is off, right? It's now off in left field. It's atypical of the rest of your kits. It needs to be replaced, thrown away, sent off for recalibration if you want to do that. Totally up to you based on the brand of the meter and how old the meter is. But it can no longer be used on any project as kits 1 through 9. That's your calibration process. Check your instruments for consistency against one another.
David, did you have anything to add?
No, I just agree with that. We would add that if you're looking at thermal hygrometers, they should be calibrated at least annually as a minimum. And I do like thermal hygrometers with a removable stick, and you can get 2 sticks and just put them in and check that, because they will get out of whack pretty easy.
Yeah, and most of them have the calibration just in the tip. So when you replace the tip, you're recalibrated.
You already recalibrated it, so there's an advantages to a removable hydro stick, so to speak.
Yep.
So go ahead, Amanda.
Off of that question, how important is it to have all 3 types of equipment for measurement in there? The meters, the thermal hygrometers, and the cameras to have, and I guess 4 some moisture sensors to have all of them.
I'll take that one, Amanda. The thermal hygrometers are not critical. They're nice and they're handy, and you can certainly justify their use. But I'll put it this way. Would you like to go to a doctor that only had part of the tools to operate on you? And yet we're professing that we're professional and charging high prices for being professional. You can't be professional if you don't have the equipment. And I'll tell you right off, the meters are the single most important tool that you have on the job, because without the meters, you don't know if you need anything else. You don't know if it's wet, you don't know if it's drying, you don't know if it's done. And you certainly can't justify what you're doing without the meters.
I can dry a house without a dehumidifier. I can even dry a house without an air mover, but I can't do it without meters.
And I can do it without heat.
Yep.
Well, I can't do it without meters.
Might take me a couple months,
yep,
but I'll know it's done.
Right.
All right, good. All right, this is kind of a specific question. In kitchens where there's a bar wall, it usually has a sheet of plywood and then drywall. What's the best way to dry since both sides have obstructions?
So the most important response to that is tagging right off of our last discussion. You got to have the meters to know if it is. I never make the assumption that something won't dry unless it has an actual vapor barrier preventing the movement of moisture. Plywood's not a vapor barrier. Drywall's not a vapor barrier. So you don't know what kind of progress you're going to make until you give it 24 hours and observe the change. If change is happening and you're making progress, great, continue doing what you're doing. If it's not happening, then change what you're doing, right? And I know that's an oversimplification, but that is the process I would apply 99.9% of the time, because usually my initial setup is at 5, 6, 7, 8, 9 p.m., right? And I don't want to get really heavy into dismantling or taking things apart. I want to get my good general drying approach, do my best at getting airflow in all of the spaces where wet surfaces exist, document how wet things are, come back in 24 hours, and then determine what's working, what isn't working, and make the changes where I need to make them. And it's amazing how often that what you discover is that you're making progress in a lot of places that you otherwise may have assumed you wouldn't, and you did some controlled demolition where you didn't need to, right? So I would always begin the process that way.
I would go and add to that, Brandon, by saying that the question is progress. People assume that we're going to have it dry in 24 hours. We don't expect that. We just want to see that it's heading in the right direction.
Yes.
And where I see a big problem is particularly on a challenging drying situation like this, is we tend to get impatient. We may see real good progress with that liquid water coming out down to 30% on moisture content in wood very quickly, and then it slows way down as we get into the declining rates of evaporation. And we get impatient about the 3rd or 4th day, and then we start ripping stuff out, when in reality, we've had this progress and it's going the right direction. It will slow down towards the tail end of the drying job. That's the slowest part of drying. And we tend to get impatient and start ripping stuff out, when if we just give it another day or 2, it'll take care of itself. I mean, provided we've got the right controls going on.
Yep. Now, if anybody who's really curious at looking at that falling drying rate, look up something called absorption isotherm. And you can see that tailing rate even in absorption isotherm. So the lower the moisture content becomes, generally speaking, the more difficult it is to remove that additional moisture.
And yet we are pressed by our clients because they're impatient, and the insurance companies who have this fictitious idea that things are going to dry in 3 days. I've had things dry in 4 hours. I've had other jobs that took 45 days to dry, and both were the most efficient way to dry. By the way, I'll put a plug in for that 3-day drying thing. Go back to the Cleanfax archive of articles. I wrote an article many years ago on 3-day drying and where that myth came from. and it's clearly laid out in there. And print that up and send it in when somebody says they're only paying for 3 days of drying. By the way, when an insurance partner says that, ask them where in their policy does it say they only pay for 3 days of drying. And what they're telling you to do is do it wrong. And you go back to the standard, quote the standard, and says equipment should be in place and running until materials have reached the predetermined drying goals, and quote that section right out of the standard.
Thanks, guys. We got time for one more question, probably. Do you have any quick documentation tips that help adjusters accept the work and get the job completed and the restore paid?
Same response we gave earlier would be the best I can think of, and that is to first make sure you're doing it daily. That's the most important part, because if you're skipping several days in your documentation or you're not documenting each of the affected assemblies, you have no leg to stand on, really. It's your hypothetical opinion versus their hypothetical opinion, and that's never a fun argument. So you need to make sure you have the data. So document daily and make sure you're documenting for all of the affected materials that you're trying to dry. That's first and foremost. The second is to take good notes. You know, when you are making adjustments to your drying process because of what you see, anything that affects the decision you're making should be documented. You know, regardless of what it is, if it had an influence on why I'm doing what I'm doing, it needs to be committed to the documentation. And in a lot of cases, that'll alleviate a lot of the questions. But in some cases, it's not going to. And sometimes if they're expecting a round peg and you give them a square peg, they're going to force you to, or try to force you to make it a round peg, right? And those are going to be some difficult conversations, but at least make sure your ducks are in a row and you've got good, solid documentation daily on each of the affected materials and their rate of progress.
I would add to that, Brandon, that you really need to understand what those numbers mean, because often people are taking these documentation, whether it's the field technician or the project manager, and they're giving it into the office or whatever. But if you don't know what those numbers mean, even though you have the numbers, there is no way to make an argument for that. And anticipate those questions. So just to give you on the documentation, when they come up with the 3-day drying thing, print up the Cleanfax article and send that in with it. Quote the IICRC S500. When you go over the 3 days, because that seems to be the trigger out there, go ahead and copy and paste that section out of the S500 and put it right on that line item and Xactimate where your air movers and dehumidifiers are over that fictional 3-day period. So give them the documentation and they have that as a reference. If they question you, then you can just simply say, hey, revert to this documentation, take a look at it, and you can go look it up yourself and see what it means.
Use F9 and Xactimate frequently.
Yep.
Okay. All right. That'll probably do it for the questions. I thank everyone who submitted questions to us. Before we conclude, I'd like to thank Cleanfax's parent association, ISSA, the Worldwide Cleaning Industry Association, as well as today's sponsor, Downhorse Instrument Company. And a very special thank you to our two expert presenters, David and Brandon. Thanks to both of you for your insight and for addressing the questions from the audience. All of our webinar attendees today will receive an email with a link to a video recording of this presentation by the end of the week, and we'll also post a link to the webinar on cleanfax.com. You can look for future Cleanfax webinars early in 2022. Thank you all for attending. Thanks again, David and Brandon, and I hope you all have a great day.